Have you ever wondered how a system can identify a fraudulent transaction among a million legitimate ones? Or how a health monitoring device can flag an unusual heartbeat? The magic behind these intelligent detections is a concept known as anomaly detection. Anomaly detection, in its simplest form, is the identification of rare items, events, or observations which raise suspicions by differing significantly from the majority of the data. Think of it as the Sherlock Holmes of data science. It's always on the lookout for anything unusual, anything that deviates from the norm. Anomalies can be broadly classified into three categories: point anomalies, contextual anomalies, and collective anomalies. Now, how does one go about detecting these anomalies? One of the popular methods is through an algorithm known as the isolation forest. Picture a forest dense and vast. Now, imagine this forest represents normal data points in a dataset. Anomalies are like the rare, exotic trees that stand out. The isolation forest algorithm isolates these anomalies. It works on the principle that isolating anomaly observations is easier because only a few conditions are needed to separate those cases from the normal observations. The anomalies are the trees that are easiest to find and isolate in our vast forest of data. But that's not the only method in our toolkit. Another powerful approach to anomaly detection is using AutoEncoders. An autoencoder is a type of artificial neural network used for learning efficient codings of input data. It's like a data compression algorithm where the compression and decompression functions are data-specific. Autoencoders work by encoding the input data, compressing it, and then reconstructing it back. The idea is that during this reconstruction, normal data will be reconstructed well, while the anomalies will not. It's like trying to reconstruct a jigsaw puzzle. The normal pieces fit perfectly, while the odd ones out just don't seem to belong. Output. So to sum up, anomaly detection is a crucial aspect of data analysis, helping identify unusual patterns and behaviors in a sea of data. It can be achieved by various methods, two of the most popular being isolation forests and autoencoders. Isolation forests work on the principle of isolating the anomaly observations, making them easier to identify, while autoencoders use a process of encoding and decoding data, with anomalies being harder to accurately reconstruct. Remember, in a world consistently generating zettabytes of data, the ability to detect the unusual can often lead to significant insights. Whether it's detecting fraud, diagnosing an illness, or even predicting a stock market crash, anomaly detection plays an indispensable role in our data-driven world. So, keep an eye out for those anomalies. They might just be the key to your next big discovery.